We're going to show you guys real quick how to phase wirelessly. It's efficient, it's extremely safe and quick. Ryan, you want to go ahead and explain to them?
Yeah. So if you look over here at our tower, we're going to have our reference probe on what we call a known A phase. So that known A phase is going to be our reference here for a minute. What we could do later on is if we don't have a known A phase, but maybe one of the other two are identified and you want to verify to make sure nothing's been rolled, you can use your other known phase. So maybe it's B, C, X, Y, Z, whatever you guys want to call it. But here we're gonna use our A phase reference.
Here you go, Ryan.
What's that?
Use the meter. I'll go over there.
Oh, I'm just gonna turn it on. So turning the tool on, we want to first verify and make sure that both tools are in the same position. Since we're just going to go over phasing with this tool, we're going to just use the tool in the degree setting. So the degree setting, this tool does not any longer care about voltage, the potential that you're using it on. It's just going to be looking at that 0, 120, and 240 crossing, or that you would get if you think of like a generator, 0, 120 degrees out, and then 240 degrees out. So here, our known phase that we're using is going to be our 0, and then the other two, say like again, we're verifying a roll, or to see if something's been rolled, or we're verifying that phasing, maybe the tape or any nomenclature is correct. This is going to be our reference. So this is going to be A. If you notice when we hook it on here, we get a white light verifying that what you're making contact with is energized. And you can think about that as, on this tool, this probe, when you get a white light, you've got a match. So you're in phase, no matter what that phase is called. When you see a white light and it's close to 0, you know that you're in phase. So I'll demonstrate that here real quick, using it on these capacitive test points. What we got going on here?
It's rolled.
Oh.
Yeah. So let them know.
So we verified here with our lights and our numbers that what we thought was our A here is not in fact our A. It's been rolled. And I guess, is that on purpose?
Yeah.
It is?
Yep.
All right. So this isn't our A phase here. Somewhere between that overhead line and our underground pad mount here, that conductor has been rolled and it's been labeled incorrectly previously. So we'll go here, test this single phase pad mount, and we get 120 degrees. So B is in fact labeled correctly since A is our reference and our sequence is ABC. We get a blue light and 120 degrees. 120 degrees would be following whatever our reference is, being A. So we know B is correct. So we'll come down here. We already have a pretty good idea that this is probably going to be our A. It's probably been rolled. And it is. We see close to 0, 350. So 350 or 360 in a circle is the same as 0. So when you're talking about angles, 0 and 360 degrees are the exact same. So we get a lagging angle of 350 degrees and a white light. So we verified that just because that transformer says C, it's not in fact C. This is actually A, and somewhere between these 2 points it's been rolled.
All right, so that's your phasing wirelessly. Thank you, Ryan. Appreciate it. If our reference was B, the sequence that we're looking for now would be BCA. B0, C120, A would be your 240. Now we know that A and C here are actually rolled, that our C is over there, our A is over here, so we know our rotation is not clockwise, it's counterclockwise.